Hey, how's it going, class? This is Mr. Miles coming at you with a podcast, and today what we're going to be doing is we're going to be looking at the last lesson from Chapter 3, and it's going to be Lesson 3, Chapter 5. Alright, so let's get to it. So what we're doing today is we're looking at plant responses and growth. So, let's check it out, shall we? Now, the thing is, we're going to be looking at first, we're going to be looking at three stimuli that are going to produce plant responses. And so three stimuli we're going to be talking about is we're going to be talking about things called tropisms. Now, what a tropism is a plant's response toward or away from stimulus. And you remember this word, stimuli. It's something that will trigger a response out of an organism, and a response is just an action. It's kind of like, action and reaction. That reaction part is going to be our response. And so let's look at the three different tropisms we can run into. So the first tropism we can run into is well, it'll be easier, I'll just lay them all out. We have touch, we can have gravity, and we can also have light. And light, of course, is a very big one. Now, touch, what this is going to be is whenever, I think it's Planet Earth. If you've ever seen Planet Earth and you saw when they showed the rainforest, they had this plant that would actually climb up other plants and eventually squeeze those plants, kill them, and then take their space. You've also seen vines. They use awnings to grow on. They'll grow on the side of buildings. And so we have these things, these plants that can grow off based off touch. As soon as they know that they can grow up something, they will do it, or in some nasty cases, they will use it to destroy other plants so that they can take up more of the space. You also get ones like Venus flytraps, which can respond to touch, and that's how they snap closed on the flies. The other type we're going to get gravity. Now, if you've ever seen on the side of a hill a tree growing, sometimes you can see a tree growing out like this and then up like this. And a lot of times what that's an indicator of is that it wasn't always slanted like this, that something later came and slanted it over. So this might have been flat at one point and eventually started growing up. Same thing, if you want to try this experiment, you could. If you were to take a potted plant and you were to start growing that plant, so it got about, let's say it got about this tall, and you tip the plant over to where now it's like this. Now, the whole thing is, this stem, because it's already grown out, it's already going to be out like this. But then what you'll find is the plant will then start to grow up like this. It can grow up like right angles. And it'll do this because it can detect which way gravity is. And because it can detect that, it can tell, okay, well, if gravity's this way, the sun's in the sky, I want to grow in this direction. So gravity is another thing that can be a tropism that can affect it. So the stimulus of gravity pulling down on it enables it to respond by growing in the opposite direction. And the last one we're going to get, and this is what it's always trying to get more of, because again, light is what provides it with photosynthesis, is it's gonna use light in order to grow. Now, sometimes what you can have is you can have a plant up like this. You can have a window right here. And what you'll find is the plant doesn't grow straight up in this direction a lot of the times, especially if there's not a lot of light coming through that window. It's going to try and take as much light as it can. It'll actually grow towards the window. It'll grow towards the light. And this is its response to where the light is, because again, more light means more photosynthesis. Now, the way that it's able to do this is it uses things called hormones. And these hormones are simply just chemicals inside of the plant that trigger different growth responses. So there's hormones that get turned on when it comes in contact with something else, so that through touch. There's hormones that get activated when it can sense gravity, and there's hormones that get activated when it senses light. An extremely important hormone in these plants is called auxin. Because plants have to respond fast to changes, so again, if there's just a plant growing out in the forest and nothing really changes too much around it, it'll still have hormones going, but they're not, in dire needs of responding to this new stimulus. But as soon as a new stimulus is introduced, like either a hillside moves down, or a plant gets tipped over, or if a plant gets brought inside and put next to a window, it's going to use this hormone called auxin. And auxin, what it does is it triggers the plant to grow a lot faster than it normally would. Now the whole thing is, again, the plant wouldn't always want to have this auxin turned on because, again, as you can guess, auxin also causes the plant to have to use a lot of resources in growth that it can't always use for a suspended period of time. So auxin is just used for emergencies. Now, the next thing we're going to look at is how do plants respond to seasonal changes? So how do plants know when to bloom? How do they know when to put out their seeds? Well, they do something called photoperiodism. And what photoperiodism is it'll use the length of the night in order to tell when it needs to do certain things. So you have this thing called critical night length. And so with a plant, it has these hormones, and it'll actually detect how much sunlight it's getting by seeing how much sunlight it's not getting. It actually does it the opposite of what you'd think it would do. So depending on how long the nighttime is, it uses that as an indicator of when it should, start to bloom, when it should start to put seeds out, and also depending on what kind of plant. And if you're looking on page 121, you can see that you have short day plants, long day plants, and day neutral plants. So ones that like really long days, ones that like really short days, and one that like when it's nice and medium. And the nice thing is the earth is always nice and constant throughout the seasons with how long the sunlight's going to be there. You know that June 21st is going to have the longest day, so it's going to have the shortest night. And you can look at December 21st, you know it's going to have the shortest day and the longest night. And then you know that when you have this in the spring and in the fall, you're going to have nice equal days. And the plant will actually use this critical night length, and it'll actually be measuring, taking account of how long the night actually is. So plants are actually doing a lot more things than you could ever really imagine. Now, the last thing we're going to look at is we're going to look at something called winter dormancy. And what winter dormancy is it's just a plant preparing, again, for winter. It helps it to survive freezing temperatures and the lack of water in a lot of cases, especially, well, it's going to have water around it, if you go out east or if you go up to Utah. But the problem is it's all trapped in ice, and the plant really can't use ice. Now, one of the things that ice does is ice actually expands. And it sounds like I just went completely off topic, but that's an important thing to understand, is that when water freezes, it'll actually expand. And that's just the way that the crystal structure is set up. And as it does that, you can have problems. Let's say you've probably seen this with like a Coke can. And so you have a Coke can, you freeze it, and then all of a sudden the sides burst out. And that's because as the liquid in there freezes, it'll expand and it'll break through the sides. Now remember, there's a lot of liquid being housed inside the plant's leaves and in other parts of the plant. So it has a problem. If that freezes and expands, then as you can guess, it can burst just like that Coke can, and that would destroy the plant. So the reason why you see leaves turn that red and brown is because they'll actually start getting rid of all the water, start killing off the leaves, and just using very minimal amounts of water, so that way when it freezes, it doesn't rupture the plant, it doesn't break anything inside of it. And so that's winter dormancy, as it prepares for the period of winter or when it's not really growing. So again, you're going to be looking at lesson 5 if you want to read along with the podcast and look up some stuff there. Other than that, just contact me if you have any questions, and we'll go over it then. All right, until next time, talk to you later. Bye.